Xamarin is the synonym for high-performance cross-platform applications. And what works across platforms, of course, also works great if we stay on the devices provided by one vendor. In my webinar today, that's going to be Apple. I will show you how to share your C# code across iOS, tvOS, and macOS to build a game and connect all of the platforms to an Azure backend to support two players competing against each other. My name is René Ruppert. I'm a senior content developer at Microsoft, working for Xamarin University. You can contact me via Twitter and find my projects over at GitHub, where I will also post the completed solution of this webinar. Allow me to introduce Xamarin University to you. We're a team of mobile experts whose biggest motivation is to help developers to deliver amazing native apps built with C#. A Xamarin University subscription includes live interactive mobile development training in all time zones. We offer one-on-one sessions to get your questions answered fast. We can review architectural questions, remove technical roadblocks, or you might want to get mobile strategy guidance. There's also self-guided learning to get the essential Xamarin training, which allows you to earn course credits towards certification, and you have the ability to learn at your own pace. The classes include the same content as the live versions. In total, there are more than 80 live and on-demand courses, which are broken into 8 learning tracks with constantly updated classes ranging from beginner to expert. We offer you a very flexible subscription model, including the new monthly option, which is starting at $83.25 per month, where we offer unlimited access to full course catalog, to expert mobile instructions and advice, hands-on help, and much more. You also have the opportunity to become a Xamarin certified developer, which designates those mobile developers who complete the certification track and demonstrate practical Xamarin mobile development expertise. In Xamarin University, you'll learn everything about the end-to-end tools Microsoft offers for developers to create and publish mobile apps. The Xamarin Development Platform lets you build native Android, iOS, Mac, and Windows applications, all in C#. This is what developers usually talk about when they are discussing Xamarin. And that's actually a huge part of Xamarin, but it's so much more. We also have Test Cloud, which is a UI testing solution allowing you to write outside-in tests and deploy them with your application to our collection of devices which are hosted in our testing center. The Xamarin tools enable you to build native apps written in C# for each platform. And with Hockey App, you can quickly deploy preview versions of your applications. You can get them to your testers to ensure that your app is amazing before releasing it to the public. Once your app is published, we have tools to monitor usage, to track custom events, and of course to receive crash reports should something go wrong. I know you're eager to get started, right? So here's the agenda. We'll begin with an overview of the mobile landscape and the different development approaches, followed by an intro to Xamarin and the Azure platform. And then we'll jump into the project. This is split into 3 parts. First, we're going to set up the Azure backend, and we will use Visual Studio 2017 on Windows to do this, and then with one click, deploy the project into the cloud. The game logic is completely platform agnostic. It will be used by the Apple platforms, but we could use that as well on a Xamarin Forms app, or an Android, or UWP app. Maybe you want to port the game over to those platforms later. To demonstrate SpriteKit, I will switch over to the Mac. There, I'm going to use Visual Studio for Mac, and I can open the exactly same solution that I used before on Windows. The reason why I'm switching to the Mac is that we also want to target macOS natively. No matter which devices we're using and how many devices we are using, we expect them to be connected and online. We're using them to check the temperature of our home while on vacation, or to get live updates when a flight is going to arrive. And we're using more than one device to consume and interact with that data. If you just take a look at your desk right now, it's very likely that you're sitting in front of a desktop computer or a notebook. And many of us will have a phone and a tablet close by. Now, this isn't unusual for developers, but we're seeing casual users carrying 2 or more devices with them, and they expect to be able to switch between those devices depending on what they are looking to accomplish. And it's not just work. We see smart devices out there in all aspects of our lives, including entertainment, athletics, and healthcare. All of these devices, and more importantly, the apps that they are running, they need to work everywhere. Cross-platform, across network types, and of course, across country borders. And we should ask ourselves, What do we need to reach our users? How do we know that we create an app that looks great everywhere and runs great everywhere? There are three big ecosystems out there: iOS, Windows, and Android. If we write an app, that means that we're going to create some business logic and the UI. Using the traditional development approach, we would build our iOS app using Xcode, and we would write code in Swift or Objective-C, built on the iOS frameworks. Well, then we decide to move over to the Windows platform. All right, so that means rewriting our business logic, this time using Visual Studio, and we write C# code based on the .NET library. And finally, if we target Android, well, now we gotta open up Android Studio, write our business logic a third time, this time in Java, and of course, once more a different UI. Now you can imagine that that's a lot of work, it's hard to maintain, and not a single line of code is shared. What we really want is the ability to write apps that can take full advantage of the power, the features, and the performance of each platform, but write the code in a common language, or even better, share code across these platforms to reduce the development time, and also to help keep applications synchronized across all of our supported devices. That's where Xamarin comes in. Xamarin is an app development platform where you can build apps for all of these platforms, including iOS, Android, Windows UWP, and share code across them. And not only is this for the mobile platforms, but also for Windows Desktop, of course, macOS, all of the wearables, Internet of Things, Xbox, and HoloLens. All of these can be targeted with your C# code. Today, I'm going to focus on a subset of all of these devices. That's the Mac with macOS, iOS, that means iPad and iPhone, and tvOS. Should you have any questions during the webinar, please don't hesitate to ask by using the chat window. We'll be more than happy to answer your questions there. We start by looking at Microsoft Azure. This is Microsoft's application platform for the public cloud. It is a subscription model that's publicly available to anyone who wants to use it. It supports both infrastructure services, such as computing resources, storage, and also networking and higher level API services, where we could, for instance, take a picture of something and have Azure tell us details about that picture. Azure was announced in 2008, released in 2010, and has grown and changed dramatically in the last several years. We're going to focus on the Azure App Service part. Azure App Services gather several existing services in a single offering. Think of it as a convenience term for a set of Azure services that are commonly used together. All the services that fall under the Azure App Service term are available for use independently. Azure App Services is available for different app types, each of which is intended to host a specific kind of workload. Please keep in mind, we're talking about Azure here. So if you hear me say app, that really means it's a service that is running in the cloud and not a client-side application. First of all, there's web apps. That's sort of the central part of this. It allows us to host websites and web applications. Then there's mobile apps for hosting mobile app backends, where we can expose data, we can offer authentication services, and support cross-platform push notifications. Next, there's logic apps. Here we can automate our business processes using a workflow-like orchestration engine. And there's API apps, where you can host cloud-based APIs in the form of web services. And last but not least, there are backend functions that allow you to write server-side logic that can manipulate our server-side databases or react to events that occur within the cloud. From the client's perspective, there's SDKs. For instance, we can use .NET with C#, Visual Basic .NET, or any other .NET language to be able to hit Azure. You can also use common web technologies such as Node.js, PHP, Ruby, or you can use native SDKs that sit on top of iOS and Android. So there you can write Objective-C, Swift, or Java code. We're going to focus predominantly on mobile apps as we move forward, because we're talking about Xamarin applications. So why am I using a game to demonstrate the abilities of Xamarin and Azure? Well, that's easily answered. Because I love building games. Back in the early 1990s, I used Turbo Pascal to create a couple of casual games that surely nobody remembers today. I made them for myself and for my friends, and I enjoyed the challenge of optimizing every single CPU cycle We did this by using assembler. I loved creating those pixelated graphics, make sure that the result is a game that's simple, fun to play. Those games required a PC running DOS with an MZGA graphics card, and that was the one and only platform that they worked on. Fast forward to 2017. My passion for gaming really is unchanged, but the tools and platforms are very different. Today I can use Visual Studio on Windows or on Mac. I can share my code, target iOS, Android, Windows, Mac, Xbox, many other platforms. And because of this variety of target platforms, it becomes important that the main parts of my code are shareable. And that's true even when limiting the platforms to iOS, tvOS, and macOS. The game I'm using for the demo today is inspired by the famous board game Connect 4. I'm pretty sure you have played it. It is a variation of tic-tac-toe, but instead of having 3 items in one row, you gotta get 4 equal coins in one row. Here we see the game board, and players are taking turns to drop either a red or a blue coin into one of the columns. So here the red player is doing a turn, followed by the blue one, and then the red one again, and here he has won the game. 4 items can be either horizontally, vertically, or diagonally in one row. So how would we play that game? Well, since it's a 2-player game, we can certainly play on one device, just taking turns. One player is making a move, handing the device over to the other player, second player is making their move. Or we could play across the internet. We can submit every move to the cloud, and yeah, you guessed right, that's the Azure backend service that we're using here. And then the other device is receiving the move. And this even works across device types. So one player can play on tvOS while the other one is using iOS. Or one is playing on the Mac and the other one is playing on Windows. The technologies that we use today are Xamarin and Azure mobile apps. The game itself and its UI will be based in SpriteKit. And the majority of the game logic and also of the UI will be shared code. I'm quickly switching over to my second screen. Here we are. So let's go ahead and create the server-side part, the backend for our game. And this is really going to be trivial using an Azure mobile app, which we have in here in Visual Studio 2017. I just create a dummy project here now, because later I'll be working on a completed solution where the server already exists. Actually, I have already deployed it. I just would like to show you how to build that up. So we create that game server here. Let's just click OK. The only available template here on my machine is the Azure mobile app template. Web APIs pre-selected, all good. Let's just create that. While this is being created, let's think about the endpoints that we will need for that server. We would want to be able to submit moves to the server. So that means we're going to post something, one specific move, and the other player is supposed to read that move. Every move is going to have a unique ID. For every move that we submit, we're going to increase this ID. So I want to be able to query all these moves and select a specific one by ID. So that means we're going to have a get and a post functionality in our controller. So now this has been generated, this mobile app, and I could directly run it. This is a working example what we have here, and it has 2 controllers in there, a to-do item controller and a values controller. We want to focus on this one here, the to-do item controller. It allows us to store, well, to-do items. Now, in our case, in our game, we are not going to store to-do items, but we will want to store move entities. So what I'm going to do here, I just rename that. I see I'm going to have a move entity. And of course, my move entity will have some different properties, not just text and complete. So let me quickly pull that move entity in here. Our move entity looks something like this. It's entity data. We've got a session ID. So we'll see later that every game that we start has got a unique session. So we can have multiple games. And if I start a game, I'm going to tell my opponent the session ID so they can then read moves that belong to this specific session. We will want to drop our coins on the game board into a specific column. So that's what we store. We will want to know who submitted that move. So that's a player. And every move has got a unique number that is constantly increasing. And I want to expose that in a table that's called moves. So that's why we have this table attribute here. And I got to resolve that here. We will want to use the system component model data annotation schema. That's what we need in here. So with that out of the way, back to our to-do item controller. And our to-do item controller, of course, that also will be renamed, and that will be a moves controller, maybe something like that. That's what we find later in our completed solution. And notice how we derive from table controller here. A table controller allows us to easily expose data that can be queried using OData filters. I'm going to show you that in a bit because that's really convenient for us. So coming back to the requirements, we want to post new moves and we want to get existing moves. And you see here in this controller, there's already a lot of examples built in. We can get all items, that just returns query. We can get a specific item here with this get to do item, which has got an ID, which does a lookup, etc. So we could now code our logic in there, but because we want to keep it as simple as possible, let's just remove all this. So you see we don't need to delete at all. And I'm just going to paste this. I'm going to add a get all moves method, which is just HTTP get, and it returns query, base.query. It returns everything. And we have a create move where I submit something, and that's going to be an HTTP post. So you might say now, okay, wait a minute. Will I always query all the moves? No, we want a specific move. But I already said that everything that we expose here as a table controller is OData compliant. And because it is, we can use the get all moves and just provide a filter in the query string. And then we can filter for whatever we need. So this means if I run this now, I can run this locally or I can run it in Azure. If I run this now, I can take advantage of this OData endpoint. And in fact, I have already deployed that to Azure. So if I switch over to the browser, we see that the server that we're using here, it's located at Xamarin 4in-a-row.azurewebsites.net. That's our server. And if I look at this, it says the mobile app is up and running. So this is really there. And now let's switch over to Postman and see if it is working. So the first thing that we want to try is see if we can retrieve all moves. So here's our get, and we run this get against /tables/moves. That's where our data is stored. And of course, I have already put some data in there. Otherwise, it would just return an empty array. Now we see if I run this, I get back 2 entities now. This is the first one, move 0. And down here, we have the second one, move number is 1. So 2 entities are returned. Now, what about this OData? Well, if my second player is waiting, he will know that he wants maybe move number 1, but he's not interested in that one. And he only wants a move for a specific session ID. For this one here, maybe. Actually, no, for this one here, the 9470. So how would we filter for that? Well, it's very easy. To get a specific move, filter for something, you see we can just add a query parameter here. It's the $filter equals, and then we just specify what we want to search for. Here we are looking for a move number that equals EQ0. And if I run this now, look at that, we really only get back that specific move. Or I could say I want to search for this session ID. I'll just copy that and I say session ID equals, run this, send it out. And oh, we get an error. Why are we getting an error? Well, because our session ID is a string. I mean, it's only a numeric value here really, but it's a string, so we have to specify it as one. We just put these quotes around it, send again, and now we have filtered by session. And of course, that returns both of these entities because they have the same session ID. We can have pretty complex queries up here, but for us, really the only thing that we will need later is session ID equals this and some move number equals a given move number. So this is exactly what we will need later in our game, and then every player can always retrieve the move that they are interested in. And that's really all we need. That's our server. Azure offers a lot more. We have only used it to store our data in a SQL database. Also, what I showed you is using a .NET backend. We could have created exactly the same experience using a Node.js backend. The next thing that we need is our game logic. And generally, if we talk about Xamarin, the idea is that, well, we want to share code across platforms. Here we also have multiple platforms, although the platforms are all within the Apple universe. So it's iOS, tvOS, and it's macOS. But still, it would be nice if we had the game logic encapsulated so that it's independent of the platform. It makes it easier to share it across the Apple platforms. It makes it also testable independently of any UI. And it makes it portable to other platforms. So I'll leave it up to you as an exercise, maybe, that you port this game here to Android or to Xamarin Forms or whatever other platform you have in mind. Now let me show you the game logic. The game logic will later be included in the solution into a separate PCL, which we have here. It's what I call the 4-in-a-row engine. Really, game logic might be the better word. When we have a look at this, here is our game logic. So what is the game about? Remember the slides that we saw. We have a game board with different columns, and 2 players are taking turns and they drop a coin into a specific column. And if we have 4 coins in a row, then the game is won. So that already tells us a lot about the ingredients. We will need a game logic where we can define the columns and the rows. We do this here in the constructor. It defaults to 6 rows and 7 columns. We have a reset method. Well, that resets the entire gameplay, sets player 1, clears the game field. Our game field is just a list of lists, and every entry in that game field is a coin. And if I peek into what a coin is, you see that a coin is something that is owned by a player, player 1 or player 2. It belongs into a specific row and column, and a coin is potentially part of 4 coins in a row. So this is something the logic here will detect for us. Whenever you drop a coin, it will immediately reevaluate everything and figure out, is this part of 4 coins, horizontally, vertically, or diagonally arranged. That's all we have in here. And with the current player, this is alternating. Player 1 is taking a turn, then player 2. Every time a coin has been dropped into the game board, the turn number increases. And here is the most important method. It's called drop coin. And we simply tell the logic where we would like to drop a coin into. So here we specify the 0-based column index. It does all the sanity checks. It creates a new coin at the given for the given column. It will figure out which row we are currently on, and then the player will change. The important internal bit of the game logic is this update game status method. So here it is evaluating everything. It's evaluating the game board. It remembers all the coins, or it finds all the coins that are part of 4 in a row. And then it tries to figure out if the game is won. So the game is won if either player 1 or player 2 has got 4 equal coins in one row. So here we have that. If neither player 1 nor player 2 has won, the game is considered to be in progress. And there's one other alternative, that's a tie. So if the board is full, no more coins can be added, and neither one of the players has got 4 in a row, well, then the game is also over, and you will have to do another match to find out who's the better player. And next, we have the game status changed event that is part of the game logic. And this is really all that an application needs that wants to visualize the current game state. They just need to listen to this game status changed, and whenever that happens, they know, oh, okay, a new coin has been added here and there into that column, or player 1 has won or player 2 has won. They just need to listen to what that event is telling them and update their visualization accordingly. And this allows us to run this game really on any platform. And like I said, in order to test it, I created a text-only version. So now I want to switch over to the Mac, to Visual Studio on Mac, and there we will have a look at the SpriteKit projects, one for each platform that we want to support. So let me switch over there. Just gotta make sure that I'm showing the right monitor. Here we go. And if you wonder now, oh, why do I have to switch over to the Mac? Can't I work with the Xamarin in Visual Studio for Windows? Yeah, you can. The problem that we have here kind of is that we want to support a platform that is not available in Visual Studio on Windows, and that is the Mac. We can create iOS projects, we can create tvOS projects over in Visual Studio on Windows, but we cannot create a Mac project. So I could just create those projects now over in Windows and then switch over and add the missing one. Would also work, but I thought we're focusing on the Apple universe, so we can just as well stick here in Visual Studio on Windows, which is fine. You see, I have opened exactly the same solution here. This is the same solution that I just had open over on Windows. And in fact, if I switch over here, you can see that I'm running the exact same console version. So that already works cross-platform. I'm running this from within Visual Studio, same gain logic that we had before. That's all working fine. And over here now, we want to add the missing bits, and that's the platforms. Before I move on with the code here, let's quickly go back to the slides here and have a look at the basics. So SpriteKit is a 2D gaming framework. And the idea of SpriteKit is that everything is organized in a hierarchy. And this hierarchy is node-based. Kind of like you add child views to parent views or subviews to superviews, you will add child nodes to parent nodes. And whenever you change a node, so for instance you change the position of one node, all of the child nodes will be affected too. And a node can either be visual or it can be just there to organize your content. So you could have one root node, and we will do this later. We will have one root node in our game that helps us to organize the game board. And that node itself is not visual, but it contains nodes that are textured. Those are SK Sprite Node elements that we'll be using here. On top of that, SpriteKit also has a built-in physics engine. We're not using this here today, but that's actually very cool because you just take one of your nodes and you say, this node has a mass of X and it has got a, I don't know, a bounciness of whatever you can come up with, and it will simulate this physics world. And it will also move your sprites according to these physical calculations. So that's pretty powerful. And all of this works across the platforms that Apple offers. So we can use the exact same API on macOS, on iOS, on tvOS, and even partially on watchOS. So it's very, very trivial to port a game to all of these platforms and share code between them. What we have to consider, however, is the fact that the input methods differ. And we'll get to this if we look at the code. So the macOS typically we have the mouse as the input device. On iOS and on watchOS, it's touch-based. And on tvOS, we have a remote control or we have an actual game controller. So this is something where we'll have to come up with a smart solution. But now back to our project and we dive a bit into the code. So how should we handle that? Well, we saw on the slides that SpriteKit-based games, they work with nodes. SpriteKit is a node-based 2D gaming framework. And I want to show you how to set up the initial view nodes. We want to create the background of our game field. And we also want to learn how can we share code across the three platforms that we want to support. And it all starts with a template. So here I've created a platforms folder and we just add a new project, and that will be an iOS SpriteKit game. Now let's just do this. And we will call this 4inArow.iOS, whatever. Create this. And I probably don't want to create that under the console folder here. Just add it there. Looking good. And we will base everything on that iOS version here. So that's our master template if we want so. Just running this now, set that as a startup project, because we're getting a lot straight out of the box. If we run this, I'm going to fire up the simulator here. Wait until it's being launched. And should be ready any second. Dum-de-dum. There we go, starting, and we have our, okay, here we have the hello world. Now let me rotate that. Here we go. That's better. So this is what we get if we run this application that is based on the template. It says hello world. That's great already. And if I click somewhere in here, it's adding sprites. These sprites that we see here, they are nodes in the context of SpriteKit. A node can be something that is textured, but a node can also be just something that helps you organize your hierarchy. And we'll be creating some nodes in a bit. What is also very obvious, these sprites here, these nodes, they are animated, they are rotating. And this is also something that is very, very easily done in SpriteKit. We can just give a command kind of to some node, and it will run that command once, twice, repeat it forever. That's what we see here. We go back in here, and I like to switch over here to the most important file, gamescene.cs. The game scene, which we derive from skzine, we have also lifecycle methods. Similar to the view controller, most important one is called didMoveToView. So this is when our scene is getting attached to the view. We have that here. And this means we can set up our scene. And setting up the scene is about constructing, creating nodes. And there are different types of nodes. What you see here is an scalable node. Similar to UI label, it allows you to output some text. The base class for all nodes is skNode, which we have here. And an skNode, it doesn't have any texture. It's just a node that helps you to organize a hierarchy of subnodes. The spaceship that we just saw in the demo is something that's getting created in here in touches begin. Again, see how easy it is to work with SpriteKit if you are familiar with UIKit. It's the same touches begin because, well, what we're working with here, it is all meant to work with UIKit. So that's why we have the same events here. We're working with UI touch here. It all nicely integrates. And whenever we receive a tap on the screen, we are creating a new SK Sprite Node. A Sprite Node is something that can have a texture. In our case, that texture is a spaceship. So where's that spaceship coming from? Well, let's have a look at this assets.exe assets file here. Or we could also say it's a folder, because if we open that, we see that it contains many different assets. This is an asset catalog. And one of the entries in there is called spaceship. And here we see this texture that was just animating over there in the iOS app. The big advantage of these asset catalogs is that you can have differently sized textures for different resolutions. So here I could have some texture that is 3 times the resolution, and that will automatically be used on iPhone 7 Plus and 6 Plus because they simply have a higher screen. Of course, I would have to scale up the scene itself to compensate for that. But that makes sure that we always have nice and crisp textures everywhere. While we are already here, let's just add the texture that we will need later. After all, we want to build our board, our game board. So we just create a new image set in here. I'm going to call that background. And I only have one resolution, trying to keep it simple. And it's this one here, background scaled. So you can see it here, just a green background with a white circle on it. This is what will be used to build our game board. I add this in here. And from now on, I can access that using this background image set here. Oh, save and go back. Why not just try it? Let's just use that here. Instead of the spaceship, we can use the background. Every node that you add to the scene or that you add to a parent node, and the scene itself is also a node, so you can add to the scene directly. Every node that you add needs a specific position. And the coordinate system in SpriteKit has 0, 0 at the bottom left, with positive X going to the right and positive Y going upwards. And there's one special thing about SK Sprite Node, that 0, 0 of the sprite that you add, so the origin of that node, is in the center of the texture. And this is only for SK Sprite Node. All other nodes, their coordinate 0, 0 is at the bottom left. So it's a bit tricky to get used to, but once you know it, it's easy. So why is our ship then rotating? Well, because we run an SK action. Actions are instructions for SpriteKit to run on a given node. Here we say rotate that by angle, and we do one full rotation within 1 second. And then we tell SpriteKit to repeat this forever. And you can have multiple actions that run at the same time. So why not, while our spaceship or now our background is rotating, why not move it a bit? So we could say sprite dot run action, and the action that we want is sk action dot move by. So we want to move it by a specific delta. I'm going to move it 200 to the right and 200 upwards within 1 second, maybe, like that. So now it's going to run this action, and in parallel, it's going to repeat forever the rotation. Let's go ahead and try this. What have we done so far? We removed the SKS file. We changed the texture. I'm going to bring this up again. And we should now see a rotating background image. I also note the letterboxing now, because we are now using SpriteKit. If I click here, see how the background is rotating and it's animating 200 by 200 towards the right, wherever I click. There we go, working nicely. Stopping this here, and now for our game. What's the first thing we need? Remember the text-based, the console version, everything should be driven by that game logic, by that abstract game logic. So that's probably the first thing we need here. I'm going to insert that here real quick. And we have now some fields in there. And we also have two nodes in there. One that represents our entire game field, and one that is a background node. And the background node is that green thingy that we just added. So I want to clean up a bit in here. This did move to view. We don't need that anymore. So what would be in our did move to view? Well, we have to set up the game field. So that's the next step in here. We want to create our background node. Remember, we can just load it from that name that we used in the image set. That's step number one. And the next one is that for all of our columns and for all of our rows, we want to create one single node for the game field. So here, if we look at that, we would have a for loop looping over the columns of the game logic. And now I'm adding something in here. We could, in theory, directly add the background node into the scene, or we could add it to our game field node, both of which, or this one we haven't yet created. But instead, what I'm doing here is I'm creating a separate node just to better organize and structure my node hierarchy. For every column, I'm creating a separate node. And this gives me more flexibility. I could, for instance, animate that node. Well, it's just better to have an additional node instead of adding everything directly to the scene. So we keep this in here. And you can see that every node also can have a name. We can identify nodes by name, very useful. It supports a regular expression like search, so this is very powerful. And we position that within the parent node. And we're going to add it in a second here. Oh, let's see, we want to create the rows now. So within every column, we have multiple rows. And here's the interesting bit. Every element now is a background node. So it's this one that we created here. But we can't add the same element, the same node over and over again. So we have to clone it. And that's what you can do by using the copy method here of the SK node. And notice how we're also adjusting the C position. This determines in which order the sprites will be drawn. So we want to make sure that that background node is drawn before we draw anything else. But it should be drawn after the coin that we add later. So the coin will probably have a C position of 1. And on top of that, we draw our background node, which is transparent. So it will look like the coin is falling behind that background node. Let's move on here. Let me see what's next. Now that we have drawn all the rows and columns, we still must make sure to add all of our nodes into the scene. So that would be the next step here. So here we adjust the position of our background node. Remember, the anchor point or the origin of a sprite node is in the center, so we must compensate for that by adding half of the width, also half of the height. And then we add our background node clone into that column node that we created here. So now every column node has got some background nodes which represent the rows. That's this one. And the next step, of course, in here is that we want to add the column node now into our game field. So game field node is just a regular node. It doesn't have any texture or anything. It's just there to organize our content. And finally, well, what is missing? Our game field node is not part of the scene yet. We're going to make sure to position and add that too. So we position this at 0, 0 at the bottom left, and we add it. Now let's go ahead and run this, and we should see a game field that has exactly the correct number of rows and columns as it's defined in the game logic. Let me bring this up here. And really, we have this. I can still click here. And you see this animation, that's why I said we want to keep it in, that now our rotating background node is behind this game field. And that's exactly the effect that we want later. We want the coin to drop down here and make it look like it's falling behind that grid. So that's this one. The next challenge for us is now, how can we reuse all of that code on tvOS and on macOS? The first thing that we have to do is add the new projects. Let me close this here. So I want to close this solution and instead switch over to a copy of that one. Where is it? There it is. Simply because adding all of these projects, it really takes a long time. So where's my Solution Explorer? Here it is. If you look at our platforms folder in here, which is a solution folder, we still have the iOS version, but I added a version for macOS and tvOS. If we look at the structure, it's very, very similar to the iOS version. So the macOS version has got an app delegate. There's also a game scene. You can spot here that I already added something. We'll get to that in a bit. And again, tvOS, once more, exactly same structure. SpriteKit is the same API across all 3 platforms, even 4 platforms. We could also support Apple Watch, by the way. Right, so what has changed in the iOS solution in here? I want to focus on the game scene. Notice first that I made my game scene here a partial class. And if we scroll further down, we notice that this touchesBegan method that was in there, that was removed. And I put this touchesBegan into the other partial class, GameScene.iOS. Here it is, touchesBegan. And I extracted the code that would add the rotating spaceship. So it's in a separate method, which we find in here. There it is. We can add a rotating spaceship at a specific location. So how can we now share that code across all platforms and still have platform-specific logic? Because if we run on macOS, there is no touchesBegan. There we have mouse input or we have keyword input. And the answer is, well, either use a shared project, or in our case, we're going to use good old simple file linking. So you see here the macOS version has got a game scene, which I will remove. Let's delete that. And instead, I add the one that already exists over in iOS. I'm going to add a file in here. And this is on my desktop. It's in the copy. We have the iOS version. And here's our game scene. And now we want to make sure to add a link to the file. So we have the file only in one place. And it's in here. I can open this. And here we find the exact same logic. Here's our add spaceship. But this time we have a GameScene.macOS.cs, which is the other half of the partial class. And in here we are reacting to mouse down instead of the touchesBegan. And on tvOS, same logic. We can repeat this. We're going to remove the game scene from here. Remove, delete, add an existing file. We'll go desktop. Yeah, copy iOS and game scene. Again, make sure to link that. Boom, here it is. And now something interesting. On tvOS, there's again touchesBegan. So tvOS is mapping the events of the remote to these touch events. But we potentially want to support a separate controller, a game controller. So it's good to have this in its own dedicated class. Now let's see if we can run the macOS version. We have already seen iOS, so I'm just going to switch to macOS here. Build. Oh, and we got some errors in here. We have to fix those. Well, of course, these are separate projects. We want to make sure to reference the game logic. Here, added the references, projects. I want to reference the engine in here, and I hope that's it. Oh, here's one more. So you see we are using UIKit. Well, we don't have UIKit on the Mac. What can we do? Well, thanks to file linking, we could just say if we are on iOS, then we want to use UIKit. And we see if that helps. Because otherwise we potentially have to reference or use AppKit instead. And we see this is working. What is different though, we're using the wrong scale mode, but I can click here and I have these animations now running in a native Mac app. If we want to fix the scaling, the Mac setup is a bit different. There is no controller. Everything is generated in the app delegate, but it's the same properties. So we have aspect fill here. We can switch that to aspect fit, and then it should work. Just rebuild. And there we go, that's better. Now we have our game field over on the Mac. Easy as that, all code shared. What about tvOS now? Well, tvOS, switch to tvOS. And the nice thing about tvOS is that it's also running UIKit. So, of course, we're missing that reference again, and references for engine. So we have to change this here if we are on iOS or tvOS. Then we can also use UIKit. Fire it up. Oh, there's another error. Oh yeah, this is something I did not mention, so it cannot find the game scene. Well, if I create the solution, the default namespace will be the one of the project, which would be for neuro.tvOS here. But I moved the game scene into a different namespace. I just called it for neuro.game here. And so that means we have to use it. The reason why I did that is that if I share this file across all platforms, I want to make sure that it's using the same namespace. Otherwise, I would have to put if-defs around the namespace declaration. And I think we can just skip that part. So it's now firing up the tvOS simulator. There we go. Starting the app. And here's our app again, wrong scaling mode once more, so you know how to fix that. Now it's interesting, I cannot tap here. Why? Well, simply imagine that this is a television. You don't run to your television and start tapping on it. Instead, you use a remote. So here on the hardware, we can show the Apple TV remote simulator, and I can click here, and it's adding our sprites in there. Another interesting aspect of tvOS is that no matter where I tap on that remote, it's always the same location. So our touch up inside in here, our touches began, it will always deliver the center of the scene. On tvOS, we will have to implement a different type of navigation. One where we can navigate left, right to the next, well, focusable element, whether that's a button or in our case, a column, that is up to us. So once more, I'm going to switch over to a more complete version of the entire solution. Unfortunately, we don't have time to go through all the details, but in this last part, we want to focus on adding the complete game, of course, show you that, and then add in our Azure connection. That's really the interesting part. So let me close this here. Here we go, close solution, and let me open the next one. So that would be number 3 here, that one. And this is now already the complete version here. So don't be surprised if there's a lot of new stuff in there. You see there's one more project, our Azure connector. We're going to cover that in a bit. But first, open the platforms, the usual suspects. And yeah, I think I'm just going to run this now. I'm going to run the Mac version, show you what has changed, but also what is still missing. And first obvious thing is we see some sort of menu here. Now remember the first demo that I did, that was running the solution that was created directly from the template. It showed hello world and it was using an SK label. So you can of course create everything with SpriteKit, or you can use whatever the platform offers. And here on the Mac we can use NS Alert, and on iOS and on tvOS we can use a UI alert controller. So here I went with this second option and just thought, well, let's use UIKit or AppKit, and I can start a local game here. And you see I'm also making use of SK label node here, so adding strings to directly to our game field. And it now tells me that player 1 is supposed to make the first move, and I would make that move by clicking somewhere. However, nothing happens because that's the part that is still missing. So that's something we're going to do together. And whenever I click, you see that it's now player 2's turn, player 1, etc. So that logic is all in. Now let's have a look at this. And my master is always the iOS version, so I'm still using the same sort of code sharing, using file linking. Here you can already spot a to-do. So that's the bit that we're missing. But I think I'm going to walk you through the solution first, so you have an idea of what has changed. And although this is a simple game, it's still a lot of code. How much is there? So you see the game scene is approximately 330 lines of code. So let's walk through this. We have already seen did move to view. That's what we implemented, where we added the game field. You see that's approximately the same here. But here's one interesting thing. The engine or the game logic is what is driving everything. So here we are subscribing to the game logic's game status changed event. And here is the implementation. So that means we just tell the engine we want to drop a coin in column X. So we call that method, and the engine is going to respond to us via that event here. And it lets us know, hey, okay, a coin was really dropped. That happens if the column is not full, or maybe no coin was dropped. Well, then we don't want to show anything in our UI. But in case a coin gets dropped, we can call our visualization. Similar to the console version that I showed in the beginning. We want to output the current game field, and here outputting or updating the current game field means if the engine said, if the game logic said, yep, coin was successfully inserted into a specific column, well, then let's animate that, let's visualize that. So that's why we have this drop coin sprite async method. And I'm going to jump right there before we move on with the remaining parts of this code here. So here we have this to do. Now let's think about that. What do we need? Well, we are told here into which column the coin is supposed to be dropped. This means we need some sort of coin sprite, visualize that. And how do we add that? Well, yeah, exactly. It's in the assets catalog. So if I double click this, it's already in here. You see I've got a coin 1 and coin 2, a red one and a blue one. And these assets, they exist on all platforms. So I've copied them to the Mac and to tvOS. So we're going to use coin 1 and coin 2. Oh, puzzle piece number 1. Then the second thing that we need is some sort of animation. So it's not that we just add that coin sprite onto the screen. We want to place it at the top of the column in question and then let it fall down. I need some sort of animation. And look at this here. See how my method is an async method? The power of C# and .NET in general. When rotating that spaceship in the demo, we had this run action method and was repeating forever, or we could repeat 3 times. But what if we wanted to wait for an animation to complete? And using async and await, this is really beautiful code that we're going to write here. So let's start with the first bit. We will need to know how many coins are there in the column that we have just, or that the game logic has just dropped the coin into. Because depending on how many coins we have to figure out the location of our coin visually. So that's the first bit here. And then we need to know, well, where should we add it? Or which kind of coin first? That's what we should add first. So we create a Sprite node from an image with a given name. And again, the game logic tells us what to do. If the current player is player 1, that means that we will have to drop a coin that belongs to player 2 and vice versa. So we simply create a new Sprite node here and prepare it. Also, see, we're giving it a name here because later we want to show some fancy animation if the player wants, so we can identify those coins. Wait, so now we have the sprite. What's next? Well, remember how I said that it makes sense to organize your nodes? So we created this column node. I go back up here to our did move to view method. Here we created the individual columns, and for every column we had this separate column node. And now this comes really handy because I can identify that node via the name. Here we have it. It's called call node and the column index. I'm going to go back down here. Where's our drop coin async method? I missed it. Here it is. So I'm getting the child node, the column node of interest, and that's where I will add the just created coin into. And that's the next step in here. We need to figure out where to place it initially and where it will land in the end. So we need a start and an end position. So the start position, trivial, because it's going to be at the very top of this column node. So the coordinates that we have here, they are relative to this column node. That means the X position is the center of that column node, which has the same width as the background node. Oh, one more interesting bit here. Might be tempting to not use background node.frame.width here, but you might wonder, why are we not using column node.frame.width? Wouldn't it be logical? This is something that is a bit counterintuitive. A node that is not a Sprite node doesn't have a frame. So the frame of our column node will be 0, 0. It doesn't have a width, it doesn't have a height. That's simply because you can add an arbitrary amount of nodes to that parent node. So what should the size be? It's not really defined. So that's why we have to know what the actual content is, and we know that we added a background node in there, and we know the background node size is 84 by 84. You can alternatively calculate the size of such a node. So there's a method in here that's the calculate accumulated frame. So for every node that has child nodes, you can always figure out what is the actual size. But in my case, that's not necessary because I know what's in there. So that's why I have this background node here that is giving me the actual position. So that's the X position. And well, what about the Y position? Remember, Y coordinate 0 is at the bottom, positive Y going upwards. So I want to place it at the very top. So that's just the number of rows we have times the background node frame's height. That's at the very top. Where will it be in the end? We want to let it drop down. It will be at the same X position. But now we have to know how many coins are already in that column. Well, the game logic tells us. Get coins in column dot count tells us there are 3 coins maybe in there. Multiplying that with the height, and we know where the coin will land. So that's our start and final pos. And now let's animate that. And that's really just like this piece of code, because it is something that you cannot do in Objective-C. This is now the beauty of .NET. We are creating a move action, and the action describes which command we want to execute on that node. And we want to move it from the start position to the final position within 0.4 seconds. We can also specify the timing mode here. We want to ease that in, so it starts slowly and then begins to move faster. That's this one here. And then we finally want to go ahead and run this action. And now look at this. Not only is there a run action, there is a run action async, and we can await that. So here we could run one action, and when it's done, we would run the next one down here. This is very nice if you have complex animations. You could have some sprite that moves from A to B, and when it's there, it starts to jump or starts to climb. You can all handle that nicely with async and await. And in here, I just noticed I missed something. That is, our coin node is now moving from its current position to the final position, but it is not really positioned anywhere on the game field yet. So let's just fix that. Our coin node's position, that of course would be our start pos. There we go. And we have to add it. So add it to the column node, add child, and we add that coin node in there. There we go. So now this method is implemented, and we go back to where we left. Here we are back in our event handler on game status changed. So the logic tells us, yep, coin was added. So now we update our game field. And we want to see if that works. I'm just going to run this here. Maybe I should run the iOS version next, just to show you that we can use UIKit there. So let's start a local game. Player 1 begins. Let's drop in column 2, and you see how it's falling down. Now player 2, there we go. Player 1 again. Player 2 goes there. Player 1, player 2. And now if player 1 puts one more into column 2, then P1 will be the winner. We see, and game logic detected that, and again we just have to react, and it shows the menu again. So what was going on there? How did we make this animation? Well, again, it's all in reaction to that event. We skip over this here for a minute. We have an async method here, import game1 async. Let's jump in there. And here we just ask the game logic. Did the first player win? Well, then output a message. Did the second player win? Let them know that the second player won, or that it's a draw, that nobody has won. We show a status message. And we just ask the game logic, well, which coins are now involved in this winning row? So we just get the game field. We find all of those that are part of our 4 in row. And again, this is link here, link in action. Works cross-platform and very convenient in our case to get the winner coins. And then we simply run an animation again. So here we run a winner action, and you see winner action is just a sequence, which means many different actions executed one after another. And here we just scale all the coins. So scale them to 60%, scale them to 60% first within half a second, and then scale them back to 100%. And repeat all of this 3 times. And then every coin of these 4 is running the same action. So that's also interesting. We are not creating 4 different actions, but the action is actually immutable. So we can use the same action for many different nodes. Every coin node that is affected runs that action. We then have a delay of 4,000 here. And then we move on and show the start menu again. So this is how we can run a local game. So what about our Azure logic? Well, that's what we're going to add in next. And to do this, we want to have a look at this Azure project and see what's in there. Let me expand that. Here we go. And we find an Azure Connector.cs class. I'm going to open that right away. This is an abstract base class that I created here, and it helps us to do or to support us when dealing with our Azure backend there. So what's in there? We can start a new session, a new game session. And starting a game session means really creating a random ID. This ID is what we will submit with every move that we make. We send the move over to the server, and then we have to tell this ID our game partner. And they then join an Azure session using that ID, and the game will pull for updated moves for this specific session. So whenever we submit something, the other one will receive it. Really straightforward. So it's just doing a while loop here, and it creates random IDs until it finds one that does not exist. So I want to make sure that we don't by accident join a session that is already in progress. And then we have these helpers here, an abstract does session exist async, make move async. Here we submit our move to the server, and get move async, where we can request a specific move from the server. Now, because they're abstract, you can of course implement a fake version of that, which doesn't really talk to the server. And if you look at the completed repo on GitHub, you will find exactly such a thing. We have in here a singleton, which returns the one and only Azure connector. And here it is using the EasyTable Azure connector. EasyTable, because we created this Azure backend using the table controller. So that's why I named it this way. Let's have a look at this. EasyTable Azure connector. A lot of to-dos in there. We have to fill in the gaps, and actually there's one more to-do up here. So we have to set it up too. Here we have to implement the communication with our server. So what we need is, we already have it here, is some sort of HTTP client. Well, let's just set that up. We put that in here. We have our HTTP client. We configure the client's base address. We point it to the Xamarin 4 in a row.azurewebsites.net URL. Make sure that we add the Zumo API version header, that's always required, and configure the timeout. I don't know what the default is, but 30 seconds sounds reasonable to me. That's the first part. Now, what about does session exist async? How could we figure out if a session already exists? Well, if we query for a move with a specific session ID and at least one turn or move is returned, well, then we know the session is already there. And we know how to do this using OData queries. There we go. We just go ahead, and I want to split that up a bit. We just go ahead, we get string async against /moves, and we add this filter. We want to check, is there a session ID well, for the session that we request here. And the extra step that we have to take here is we have to deserialize that. Not really difficult. I added a NuGet package that's json.net, and that one works on tvOS. So I'm able to deserialize that here into a list of move entities. And then I can just return whether there is more than one. Well, then we know that, or one or more sessions, then we know it exists. Done. Easy as that. What about making a move? Making a move means posting something. I have that here. So again, I want to separate this. So this time the other way around. We have a move entity and we serialize it. And we post async to table/moves, some string content, JSON encoded. Done. That's it. What about getting a move? Even easier. Paste that in here. We're again making use of the OData filtering. We say we want a move for a specific session with a given move number. So just compare. Deserialize what is returned. That's a list of moves because potentially there's more moves that are returned here. And we get the first of these returned ones. That's it. If there is no move, this is going to return null. Now you see the whole implementation with the blank lines is 57 lines of code. Doesn't really get any easier by using the client SDK, but would be possible, of course, on iOS and macOS. But for tvOS, we would have to write something else. One word about this, though, you see there's no error handling in there. Whenever you're dealing with web services or RESTful endpoints, make sure that you have try catches everywhere. You've got to deal with the errors. Don't let the app crash. But to keep it simple, I'm skipping this in here. So now we have this connector. Well, what are we going to do with it? Well, let's have a look at that. We switch over to our game scene. We are informed if a coin was added. So let's assume we are making the first move. We're dropping the red coin here. The game logic calls us back, and we know what type of game we have here. So have we started an Azure game? If yes, we just see who is the current player. And if it is us who started the game, well, then we send our move over to Azure. So here we have the Azure Connectors instance, make move async. We simply create a move entity with the information and send that over. The other player, he will also be in here. And he'll be in this if branch here. He will figure out, okay, my game is in progress. I'm participating in an Azure game. So I have to get the next move from the server. Here we have it. Get move async. I'd say we want to fire that up, give it a try. I'm gonna, how should we handle that? So I'm gonna run the Mac game here and make the Mac the one who's starting the Azure game, and then run the iOS version and let it join the Azure game. So here's the moment. We have the Mac version. And actually I gotta stop debugging here and run the Mac version now directly, because we also have to run this one here. So I'm start this one, run this on the iPhone. And while this is booting up, we find this here in the file system. So no, that's not what I wanted. Where's the Mac? 4 in a row, Mac, bin, binary, debug, and there should be our app. So there it is. There we go. This one, simulator is still booting. And here's the simulator. Now let me rotate that around. Oh, here you also see how iOS is using UIKit and the Mac is using AppKit. So we want to let the Mac start a game here. Creating session, please wait. And it should pop up a game ID. Here it is, 57763. Switch over to the simulator, join an Azure game, and we enter 57763. And we submit here. And let's cancel that. We don't need that pop-up. Player 1 red, make your turn. So we are at player 1. And this one here, waiting for other player. And look down here how every second it's polling for the next move. Oh, now here we go. Player 1 drops a coin in there, sending turn, and boom, after a second you see how the coin is dropping over there. Now the game logic switched players. Now it's the iOS turn. There we go, drop that, and wait a second, and boom, here it comes. If we continue this, so whose turn is it? That one here. I just want to make sure that this one. There we go. This one again. I want to make sure that the logic works. There we go. And now red player wins. And we see after a while this one also starts animating. So this really works on both platforms over Azure. And here we see the session ID. And if I go over to Postman now, so that's all the moves we made. They have really been submitted over to Azure, working as designed. Now, maybe once again, what about tvOS? Because on tvOS we still have something special, and that is the navigation. So what would that look like over here? Let's just run it. Building, deploying. Oh, come on, what's wrong? Waiting for the debugger to connect. No, it doesn't want to connect. Let's just clean that here real quick. And rebuild. Booting up. Now it's working. There we go. Let's see if we can start the game here. We're gonna use the remote again. Let's play a start an Azure game. Here we go. Select that. Oh, no, why is the remote not reacting? There it is, creating game session. I should come up with a game ID, 52352. I'm gonna enter this over here in the Mac version. So join an Azure game. That is 52352. Confirm, waiting for other player. And over here, we also need to confirm. Just click here. You can see now that we have this indicator, the red outline. It's also animated, and we can use the cursor keys or the remote control, of course, to navigate here to a specific column. And that is only for the tvOS version. We select the column, and we can drop a coin by using the remote. So there we go. Now it edited. The remote is kind of strange because you don't click on the remote directly. Instead, you press the Option key to trigger something. And so that does not always work. It's way better if you test that with a physical remote. But anyway, you see this is working. We go over here, and now it's our turn. It should appear over there, and there we have it, and so on. Why don't we go back to Visual Studio and have a look at the tvOS specific navigation part. You see that I introduced a specific subclass of SK node that's a focus node. And you have to do this if you want to make a node selectable on tvOS. It has got this can become focused property, and you cannot set that. For some strange reason, you must override it and then return true. So that's the first thing. And the second thing is user interaction must be enabled on such a node. And by doing this, tvOS will take care of making this focusable. It does this via a focus environment. And you just tell it where to go. So whenever the focus is updated, you have to find the next element. In my case, that's the next node. And here I'm creating this red outline. That's a shape node. A shape node is a node that doesn't have a texture, but actually some sort of path. In my case, a rounded rectangle. And I animate that. I'm again using some scaling action here to highlight the currently selected column. And with that, we can figure out where we want to drop that coin. All right. So with that, we have reached the end of the demo part. I'm going to switch back to the slides now and point you to the repository. You can find the complete project over on GitHub. We created that short URL for you, so check it out. The tools that I used today, Visual Studio 2017 for Windows, Visual Studio for Mac, and the entire Xamarin framework, all of this is available for free. You find it on visualstudio.com and on xamarin.com. And if you want to learn more about all these different platforms, about more advanced topics, then check out Xamarin University. You can start your free trial today, aka ms/buy Xamarin University is your entry point. And hopefully you'll sign up for a complete subscription to get access to all of our existing courses, more than 18 total. You can get a monthly subscription over at the Visual Studio Marketplace starting at $83.25 per month. And you can pay for this using your existing Azure subscription. We have very flexible billing options, so hopefully I'm going to see you in one of my classes. I'd like to thank you for attending this webinar. Still would like to point you to the upcoming webinars. There will be one about customizing Xamarin Forms UI. There will be one that I'm really looking forward that is about machine learning with Azure. And we have one that will deal with Skia Sharp, a cross-platform graphic library that you can use to add great animations to your application and of course make them run on iOS, Android, UWP, and so on. We're still around for your questions. Please put them into the chat window. We're always happy to assist. Thanks and bye.